Welcome, geometry students, to the homework help video. In this video, we are going to focus on numbers 1 through 36. So let's go ahead and get started looking at these problems. Here we go. Okay, problem number 1. Numbers 1 through 4, the directions say to find the value of x. Now, students, here's what I want you to learn. Please listen carefully. Whenever you have a right triangle, like we have right here, and there's an altitude drawn inside of that right triangle, and the altitude is drawn from the right angle to the hypotenuse like this, and of course, by definition, an altitude forms a right angle. Okay? When that happens, this side right here, students, is the geometric mean of this length here, and the entire length of the hypotenuse. Now, students, it is always very, very important to ask yourself which number is the geometric mean of the other two numbers. Okay? Now, let me go over this again. This number here, this measurement here, this length here, is always the geometric mean of these two lengths here. This and this. Okay? So if 6 is my geometric mean, remember, that goes in two places, above and below in the fraction. So this number here is the geometric mean of these two numbers here. So because this number here is the geometric mean of these two numbers, you put the 6 here and here, or you could put the 6 here and here, and not here. It doesn't matter, just as long as they are diagonally across from each other. Okay? Then this number here, 9, can go here or here. It doesn't matter. And x can go here or here. It doesn't matter. Okay? And now we're all set. Cross multiply. 9 times x is 9x. 6 times 6 is 36. Divide both sides by 9, and x equals 4. So please don't forget, students, that this length here is the geometric mean of this smaller segment here and the entire hypotenuse here. Okay? Alright, number 2. Okay, students, we have the exact same kind of problem again, okay? Look, we have a right angle with an altitude drawn inside the right triangle, okay? Now, this segment here is the geometric mean of this little segment here and this big segment here, okay? So, this is your geometric mean, so you write it here and here, okay? 9 and 25 go here and here. It doesn't matter which place you put them. And now we're doing good. X times x is x squared. 25 times 9 is 225. And the square root of 225, if we take the square root of both sides, the square root of x squared is x. And the square root of 225 is 15. Okay? So the answer should be 15. Alright? Okay, let's continue on. Number 3. Now this is a little different. Please listen carefully. Once again, we have a right triangle, just like the last two problems, okay? And then inside that right triangle, we have an altitude drawn from the right angle to the hypotenuse. So that part is all the same. However, what's different is we're no longer dealing with this leg here, or we're no longer dealing with this leg here. Now we're dealing with the length of the altitude. So here's what you need to know. The length of the altitude is always the geometric mean of this length here and this length here. Always. Let me go over that again. This length here is always the geometric mean of this length and this length. So x plus 3 is my geometric mean. So I'm going to put that here, and I'm going to put that here. X plus 3 is the geometric mean of these two numbers here. So your 9 and 4 would go here and here, or you could swap them, it doesn't matter. 9 times 4 is 36. X plus 3 times x plus 3. Now, students sometimes make mistakes here, so please watch carefully. X plus 3 times x plus 3 would be x times x. x times 3. Now take your 3. 3 times x. 3 times 3. So you took this x and you multiplied it by both terms over here. You took this 3 and multiplied by both terms over here. And you end up with x squared plus 3x plus 3x would be 6x plus 9. Now what I've taught you to do is to factor, okay? And you never want to factor unless you have one side equal to 0. So in order to get one side equal to 0, I'm going to bring this positive 36 over and make it a negative 36. So now I'm left with 0 equals x squared plus 6x minus 25. Okay? Now let's continue on. Sorry students, I just found my mistake. I paused the video there because it did not look correct. It would not be 25, sorry about that. It would be 27, okay? So now we're ready to factor this. So you say to yourself, what two numbers when multiplied together give me a negative 27, but when added together give me a positive 6? Well, I think of these two numbers right here, a positive 3 and a negative 9. If you multiply those two numbers, you get negative 27. I got it backwards, sorry about that. Negative 3, positive 9, there we go. If you multiply those, you'll get a negative 27. But if you add those, you'll get a positive 6. So the factorization would be x minus 3, x plus 9. Okay? Now, if you take each group and set each group equal to 0 and solve, you will have your answer. Bring your 3 over, make it a negative 3. Or a positive 3, excuse me. Bring your 9 over and make it a negative 9. Now, please don't circle both of these answers like I have done. Don't do that. Negative 9 does not work. Think about it, students. If you put negative 9 in for x right here, negative 9 plus 3 is negative 6. How can a length be negative? That's not possible, okay? So the only answer that makes sense that works is 3. There's your answer. You reject this answer here. So 3 goes right here. 3 plus 3 is 6. So the whole length is 6. X equals 3. X equals 3, okay? Watch this again if you need to, students. Make sure you know how to do these. Alright, number 4. Now this is like the first two that we did. We have a leg right here, which is the geometric mean of this segment here and the entire segment here, okay? So, now be careful guys. I can see me on the test or a quiz not giving you this number here and calling this segment here 21. And I would expect you to know that this side here is not the geometric mean of this segment and this segment. No, it is the geometric mean of this segment and the entire segment. So I would expect you to add these two numbers together and get 48 right here. Okay? You need to know your stuff, guys. You need to know that this leg here is the geometric mean, not of this segment and this segment, but of this segment and the entire segment. Now, don't get confused, okay? Do we ever use just this segment here and this segment here? Yes, when we're trying to find the length of the altitude. The length of the altitude is the geometric mean of this length and this length, and we just use that in this last problem here, this length and this length, but not on this problem, okay? This is a leg right here. So this leg is the geometric mean of this segment and the entire segment, okay? So here we go. My geometric mean is x plus 16. So I'll put that here, and I'll put it here. Then my two numbers, x plus 16 is the geometric mean of what two numbers? 27 and 48. So I'll put one here and one here. 27 and 48. Now, let's go ahead and multiply first of all 27 times 48. And if you do that correctly, you're going to get 1,296. X plus 16 times x plus 16. Now, take the x and multiply it by both terms. X times x, x times 16. Now take your 16, multiply it by both terms. 16x, and then 16 times 16 would be 256. Now, when you combine your like terms, you end up with x squared plus 32x plus 256, okay? Now, we're going to bring the 1296 over and make it negative so that we have one side equal to 0. So 0 equals x squared plus 32x. And now let's see what we have here. 256 minus 1296 gives us 1040 negative. Now I'm not going to lie to you, this is a pretty tough one to factor out, okay? So I'm going to try to do it here live in front of you and show you guys how I would do this, okay? I've got to multiply numbers together that will give me 1040, and I really don't know where to start. I know 104 times 10 would give me this, but if you add those together you won't get 32. So let me try some other numbers here. 1040 divided by 20. 20 times, I think I just got it, so I got a little lucky. I'm trying to think, and that was a coincidence, guys. I did not know what the answer was. I'm just trying to think of numbers that go into 1040. 10, 20 would, 5 would, 50 would not, but I'm trying to think of different numbers, and 20 does. 20 times 52 gives you 1040. Now, I need a positive 32, and I want a negative 1040, so I'm going to make my bigger number positive and my smaller number negative. Now, think about it. If I multiply these two numbers together, I get a negative 1040. If I add these two numbers together, I get a positive 32. So these are the correct factors to use. So 0 equals x minus 20, x plus 52. And to be honest with you, I really should not have used the x here for multiplication because it does look like the variable x. So I'll put a dot right here. There we go. Okay guys, if you take x minus 20, set it equal to 0, then x equals 20, bring the 20 over, make it positive. X plus 52 equals 0, bring the 52 over and make it negative. And there's no way the answer can be negative 52, because if you put a negative 52 right here for x, negative 52 plus 16 would give you a negative 36, okay? And that's not possible. You can't have a negative length. Excuse me for yawning, I apologize. However, 20 in for x works just fine, because 20 plus 16 is 36, so your whole length is 16, so the answer is 20. X equals 20, and cross this off, okay? Alright, numbers 5 through 8, we're just using Pythagorean's theorem, and it says to write your answer in radical form. So these should be pretty easy, guys, okay? Anytime you have a right triangle and you know two sides, you can find the third side by using Pythagorean's theorem. So Pythagorean's theorem, of course, is L squared plus L squared equals H squared, okay? So that's Pythagorean's theorem. One leg is 6, so 6 squared plus my other leg is 5 squared equals x squared. 36 plus 25 equals x squared. 61 equals x squared. Now take the square root of both sides. Square root of 61 equals x. Now students, remember your perfect squares. You must learn to simplify radicals. I expect you to do that. You must learn to simplify radicals if they can be simplified, okay? Now if you think of your perfect squares, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, and there are others. We could continue on, but do any of these these numbers go into 61 evenly? No. So we cannot simplify. So this is the answer, okay? But learn to check and make sure that your answer cannot be simplified, okay? That's real important to do. Alright, let's continue on to number 6. Alright, now we have one leg, 8, plus my other leg equals my hypotenuse squared. So leg squared plus leg squared equals hypotenuse squared. 8 times 8 is 64. 12 times 12 is 144. Bring the 64 over and make it a negative 64. And that will leave you with x squared equals 80. Okay? Now, take the square root of both sides. There we go. And now let's see if we can simplify the square root of 80. Do any of these numbers go into 80 evenly? Well, let's see. 16 does. 4 does too. But I always want to try to find the biggest number that goes into this number evenly. And the biggest number is 16. So 80 is the same thing as 16 times 5. Okay? Now, which one of these two numbers do I know the square root of? 16. So cross off a 16 and put a 4 on the outside because the square root of 16 is 4. So you're left over with 4 square root of 5. Okay? And that is the correct answer. 4 square root of 5. Alright, let's take a look at number 7. Alright, once again, Pythagorean's theorem. One of my legs is 12. My other leg is x. And my hypotenuse is 16. Now I think earlier we squared 16. And what did we get when we did that? We did that earlier right here. 16 times 16 is 1,296. 12 times 12 is 144. Now, subtract 144 from both sides to get x squared by itself. And you're going to be left over with 1,152. Okay, so we're going to take the square root of both sides. And when we do that, we're going to get 1,000, the square root of 1,152. Now, it's a big number. And it's not going to be easy to see if we could simplify this number using our radicals here, or excuse me, our perfect squares, but we need to see if we can. So, I would start here and start dividing these numbers into this number evenly. For example, does 4 go into 1,152? I think it does. Let's see. Let's try and see. 4 times 8, 288. So yes, 4 goes into 1,152, 288 times. Okay, now which one of these do I know the square root of? 4. So cross off the 4 and put a 2 on the outside. So now we have 2 square root of 288. But hold it, 4 would go into this number again. So now I have 2 square root of 4 times 72. Alright? And I would think that 72 also goes into this number again, I believe. Alright, so let's see here. Now students, I do hate it when I make mistakes, and I'm not sure how I did this, but I'm working along here, and if you're following along, you probably noticed right away that 16 times 16 is not 1,052. Now if I was doing this in class, students would just raise their hand and say, Mr. Earhart, you made a mistake there, and we'd fix it. Unfortunately with videos, I don't catch it until the very end, so I do apologize, but I'm sorry. So actually 256 would not go there. 256 would go right here. 16 squared is 256. I'm really, really sorry about that, okay? So you'll get 112 when you subtract 144 from 256. 16 times 16 is 256, okay? Now, I'm not sure how I made that mistake. Now, moving on, the square root of x squared is x, and the square root of 112 is the square root of 112. Now, 4 will go into that 18 times. let's see, no, that's not right, 2, 28 times, okay? So 4 goes into 112 28 times. So the square root of 4 is 2. Cross it off, put a 2 on the outside. So now I have 2 square root of 28. Well, 28 can be broken down into 4 square root of 4 times 7. Alright, now, which one of these numbers do I know the square root of? 4. So cross out the 4, put a 2 on the outside, and you multiply these together. So you're left with 4 square root of 7. Okay, now, way back here at the beginning, you could have said 16 goes into 112 7 times. And that would have been faster. 16 times 7 is 112. 16 is a perfect square. Cross it off and put a 4 on the outside. But either way, you get the correct answer, okay? Alright, so 4 square root of 7. Moving on to number 8. Okay, we have a leg. That is a 4. We have another leg. This is 6. And our hypotenuse is an x. Right? 4 times 4 is 16. 6 times 6 is 36. Add these two numbers together, you get a 52. Take the square root of both sides, and the square root of 52 equals the square root of x squared is x, okay? Now, do any of these numbers go into 52 evenly? Well, 4 does. 4 times 13 is 52. Cross off the 4 because we know the square root of 4. Put a 2 on the outside. So your final answer is 2 square root of 13, okay? 2 square root of 13. Alright, moving on to number 9. Numbers 9 and 10. The directions say to find the geometric mean of the numbers. Well, students, anytime you're given two numbers and you're told to find the geometric mean, there's two ways to do it, okay? You can put the 9 and the 25 here. And put your x here and here. Cross multiply. Cross multiply. Take the square root of both sides. The square root of x squared is x. The square root of 225 is 15. That's one way. There's a faster way though, guys. Whenever you're given two numbers and you're told to find the geometric mean, it equals the square root of those two numbers being multiplied together. That's a lot faster, okay? The geometric mean equals these two numbers here being multiplied together, and then take the square root of it. So the geometric mean equals the square root of 225, and the square root of 225 is 15, okay? So both of these methods work. This one's a little faster over here. Alright, number 10, same thing again. So I'm going to say my geometric mean equals the square root of the product of 10 and 14, okay? So my geometric mean would equal 140. 10 times 14. Now, that should be our final answer, but we might be able to simplify it, okay? So let's see if any of these numbers will go into 140 evenly. Maybe they will, maybe they won't, okay? As I go along, start at the bottom, work my way up. Or start at the top, work your way down if you want to do it. 16 goes into 140, okay? And it would be 16 times 35, I believe. Let me see here. No, that will not be correct. Hold on 1 second. 4 goes into 140. Let's see. 2, 3, 35 times, not 16. Sorry about that. 4 times 35 gives you 140. Cross off 4, put a 2 on the outside. So the answer is 2 square root of 35. Okay? There we go. Alright, numbers 11 and 12. The directions say to complete the Pythagorean triple. Okay? Complete the Pythagorean triple now. They do want you to assume that their sides are going from smallest to largest. So in this case here, you're given the two smallest sides, or the two smallest numbers, and you want to find the biggest number. So it goes over here, okay? So 12 squared is 144. 16 squared is 256. Add those together, and we'll get 0 carrier 1, 0 carrier 1, 400 equals x squared. Take the square root of both sides. The square root of 400 is 20, and the square root of x squared is x. So the number that you're missing to make this a Pythagorean triple is 20. Okay, remember a Pythagorean triple just means you're trying to find the number that that satisfies the Pythagorean theorem with those three numbers. Okay, that's all the Pythagorean triple is. Okay, students, now remember I told you in the last problem they want you to assume that these sides are listed from smallest to largest, so you're missing one of the smaller sides, like a leg of a right triangle. So x squared plus 15 squared equals 17 squared. Okay, so here we go. Squared is going to be 225. So I'm going to write that right here. And 17 squared is going to be 289. Now bring the 225 over and make it negative. And you're left with 64. Take the square root of both sides. The square root of x is x, and the square root of 64 is 8. So the number that you need to make this a Pythagorean triple is 8. Okay, moving on to numbers 13 and 14 and 15 and 16. They want you to decide whether the three numbers represent the lengths of an acute, right, or obtuse triangle. Okay, so first of all, you must, students, see which one of these is the longest side. Okay, so I'm going to take with my calculator 2 times the square root of 21, and the decimal I'm going to get for this right here is 9.16. So obviously, if this number here is 9.16, then 2 square root of 21 is longer than 7 and longer than 9. Mr. Earhart, does it really matter if we know that? Yes, because remember, your two smallest sides always are the ones that are being added together after you square them. Okay, so yes, the two smallest sides go here, and then the biggest side, the longest side, goes over here by itself. Okay, and on a test or a quiz, I'm not always going to be as nice as the book is and list these in order for you. Okay, I'm going to expect you to figure out which one's the longest one and put it over here. Well, when you square 6, you get 36. When you square 7, you get 49. Now be careful on this one. Okay, when you square this, you square the 2, which is a 4. And anytime you square a square root, you get the number on the inside, which is 21. Let's go over that again, okay? 2 square root of 21 squared means 2 square root of 21 times 2 square root of 21. So 2 times 2 is 4. And the square root of 21 times the square root of 21 is just 21. Then multiply those two numbers together, and you get 84. So 4 times 21 is 84. And over here we have 85. Okay, so I'm not sure why I put an equal sign. I should have left that blank. Okay, 85 is greater than 84. Now remember, when the sum of the square of the two smaller sides is greater than the square of the longer side, you have an acute triangle. Okay, acute triangle. All right, number 14. Obviously, our two smallest sides are 9 and 12, so they go together on one side. I'm not going to put an equal sign this time, okay, guys? We're going to leave it blank, then come over here and put 15 squared. Now, 9 times 9 is 81. 12 times 12 is 144. 15 times 15 is 225. Now, let's add these two numbers together. 81 plus 144 is 225. So, in this case, we do end up with equality. 225 equals 225. Now, whenever this happens, the left side equals the right side. That means we have a Pythagorean triple, and that means we have a right triangle. So when the left left side is larger than the right side, you have an acute triangle. When the right side is larger than the left side, you have an obtuse triangle. And when the two sides are equal, you have a right triangle, okay? Alright, let's very quickly make sure that 4 square root of 13 is the longest side. So 4 times the square root of 13 gives you 14.4. 14.422. So this side here is definitely the longer side, okay? So 8 and 12 are your two shorter sides. So we're going to square them and add them together. Then come over here, we're going to square 4 square root of 13, okay? Well, when you square 8, you get 64. When you square 12, you get 144. Okay? Now when you square this, you square the 4, that gives you 16. And when you square a square root, you get the number on the inside, and then you multiply those together. Okay? Look at that again. You square the 4 at 16, and then you square the square root of 13. And anytime you square a square root, you get a number on the inside. Okay? Now, 16 times 13 equals 208. Now, if you add these two numbers together, you will get 208. Okay? So, again, the left side equal the right side, so we have a right triangle again. Alright, number 16. 4 square root of 5. 4 square root of 5 is 8.9. So, 4 square root of 5 and 3 are your two smaller sides, okay? So I'm going to square my two smaller sides and add them together. Over here, 10 squared. Well, obviously 10 squared is 100. Over here, 3 times 3 is 9. Plus, now, when you square this, you square the 4, that gives you 16. Then you square the square root, that gives you 5. Multiply them together, and you get 80. Alright? So you end up with 89 is less than 100. Now, when these two legs that are squared and added together are less than the longer side being squared, that means you have an obtuse triangle. Okay, so we have an obtuse triangle. Alright, moving on to number 17. Alright, now, these are the really important ones, so listen. If you don't remember this from your notes, you're not going to do well on your test. You need to know that when you're dealing with a 45-90 triangle, the legs will be congruent. The hypotenuse will be square root times the leg. Or you could say the leg will be the hypotenuse divided by square root of 2. Okay? So, we have an isosceles right triangle. Now, think about that, students. If we have an isosceles right triangle, that means we have a right triangle in which the two legs are congruent. Well, students, please listen to me. Anytime you have an isosceles right triangle, anytime you have an isosceles right triangle, it's going to be a 45-90 triangle. Always, Mr. Earhart. Yes, always. Because think about it. If it's isosceles, then these two sides are congruent. If it's right, then we know we have a right angle here. And look, if this side here is congruent to this side here, then the opposite angles are congruent. So they have to be 45 and 45 to give you a total of 180 degrees. So yes, we have a 45-90 triangle. Okay. Now, they tell us it has legs of 3 square root of 2. So there's a leg and there's a leg. Now, what is the length of hypotenuse? Well, it tells you right here what to do. The hypotenuse will be square root of 2 times a leg. So I take my leg, which is 3 square root of 2, and I'm going to multiply it by what? What's it say here? The hypotenuse will equal square root of 2 times the leg. So I take my leg times square root of 2. Now, be careful here. Even though you can't see it, there's a 1 right here. So you multiply your outside numbers times your outside numbers. 3 times 1 is 3. Multiply your inside numbers times your inside numbers. Well, 2 times 2 is 4. Now, we know the square root of 4. That's a perfect square. If I said what's the square root of 4, you would say 2. So the square root of 4 is 2. So instead of having 3 times the square root of 4, I really have 3 times what? 2, which gives you 6. So the hypotenuse would be 6. Okay? Don't forget this, guys. Look. The hypotenuse will always be square root of 2 times the leg when you're dealing with a 45, 45, 90 triangle. Okay? Alright, number 18. Once again, we have an isosceles right triangle. Okay? So if we have an isosceles right triangle, we know that means we have a 45, 45, 90 triangle, okay? So here it is, 45, 45, 90. Now my hypotenuse is 26. What is the length of each leg? Well, first of all, don't forget, the legs are congruent, okay, students? So if I find this length here, it will be the same as this length here, okay? Now that's only true in a 45, 45, 90 triangle. Okay, the hypotenuse will be square root of 2 times a leg. But look at this. How do I find a leg? Well, the leg will be the hypotenuse divided by square root of 2. So all I have to do is take the hypotenuse and divide it by the square root of 2. So 26 divided by square root of 2. But hold it. Remember, I've told you guys, you cannot have a radical in the denominator. So we're going to have to rationalize the denominator and get rid of this radical. And we've talked about this, and we've done some homework on it, and hopefully you remember how to do this, okay? We're trying to get rid of the square root of 2. So in order to do that, we're going to multiply the top and the bottom by square root of 2, okay? Now, 26 times the square root of 2 is just 26 square root of 2. However, square root of 2 times square root of 2 is 2, okay? In other words, square root of 2 times square root of 2 is the square root of 4. 2 times 2. And the square root of 4 is 2. Okay? Now, this is a please, students, never reduce an outside number with an inside number, okay? This is an inside number, it's inside the radical. This is an outside number, it's outside the radical. However, you can definitely reduce outside numbers with outside numbers, okay? So, 2 goes into 26 13 times, so your final answer would be 13 square root of 2 over 1. And you do not have to put the 1 if you don't want to. And so there is your answer, okay? And so, there we go. 13 square root of 2. Alright, number 19. Okay, we have a 30, 60, 90 triangle. Now, let me pause and say this. If you do not know this information, here, students, you need to learn it before the test. Please, okay? That's really, really important. You need to know these before the test, okay? The shorter leg is half as big as the hypotenuse, or you can say the hypotenuse is twice as big as the shorter leg. You need to know that. The longer leg is square root of 3 times the shorter leg, okay? The shorter leg equals the longer leg divided by the square root of 3. So it sounds like to me, when it comes to a 30, 60, 90 triangle, the key side is the shorter side. So if you don't know the shorter side, find it quickly. And if you do know it, then you can find the other two sides very easily, okay? If you can find the shorter leg, the other legs fall into place, okay? So here we go. We have a 30, 60, 90 triangle. It has a hypotenuse of 12, of a length of 12. What are the lengths of the legs? Okay, so here's my 30, 60, 90 triangle. Okay, we're going to call this right. We're going to call this 30. We're going to call this 60, okay? And so my hypotenuse is 12. Now, watch this carefully, students. Listen to my reasoning. 30 degrees is smaller than 60 degrees, correct? Sure it is. So that means if I go directly across, this is my shorter leg because it's across from a smaller angle. Now 60 degrees is bigger than 30, so I go across from 60. This is my longer leg because it's across from a bigger angle. Does that make sense? Let me go over it again. This is a smaller angle, so go straight across. This has to be your smaller leg. 60 is bigger. Go straight across. This has to be your longer leg. Okay, now, having said that, let's see if we can find these. Okay, remember the key is finding the shorter leg. That's the key. So, the shorter leg is, let's see if I can find this. Okay, here it is right here. Look, guys. The shorter leg is half as big as the hypotenuse. Right here. The shorter leg is half as big as the hypotenuse. So, if the hypotenuse is 12, then my shorter leg will be what? 6. Now that I know my shorter leg, how do I find the longer leg? Well, it's right here. Look, guys. The longer leg is square root of 3 times the shorter leg. So, my shorter leg is is 6. I take that and multiply it by the square root of 3 because it says right here the longer leg is square root of 3 times the shorter leg. Okay, so I'm going to take my shorter leg, which is 6, and multiply it by square root of 3, and that would be the correct answer for your longer legs. 6 square root of 3. Okay, alright, let's go ahead and check these and continue on. Alright, okay, number 20, another 30, 60, 90 triangle. Okay, now they're giving us the shorter leg, which is really nice of them, okay? So here's my triangle. I'm going to call this 30, 60, 90. Now, across from 30 is your shorter leg, and they're telling you that the 30, 60, 90 triangle has a short leg with a length of 9. So this should be really easy, guys. Look right here. The shorter leg is half as big as the hypotenuse, or the hypotenuse is twice as big as the shorter leg. So if the shorter leg is 9, the hypotenuse is 18, just like that. Now, the longer leg is square root of 3 times the shorter leg. The longer leg is square root of 3 times the shorter leg. Here's my shorter leg. Multiply that by the square root of 3. 9 times the square root of 3 is just 9 square root of 3. Okay? Now, so the two legs would be 9 and 9 square root of 3. I'm sorry, they didn't ask for the two shorter leg, the shorter leg and the long leg. They asked for the hypotenuse. So the hypotenuse is 18 and the longer leg is 9 square root of 3. Okay? And there's the two answers right there. Okay? Alright, moving on to numbers 21 through 24. They want us to find the sine, cosine, and tangent of each angle. Now I'm going to go pretty fast, okay? We're going to start off with B, just because I feel like it, no certain reason. So sine, cosine, tangent. Here we go. I circled B, so go straight across. This is your opposite side. Here's your right angle. This is your hypotenuse, and this is your adjacent side over here. Okay, so here we go. Sine is opposite over hypotenuse, so 4 square root of 2 over 9. Now, can you reduce your outside numbers 4 and 9? No, you cannot. Cosine is adjacent over hypotenuse, so 7 over 9. Adjacent over hypotenuse. Tangent is opposite, opposite over adjacent. Opposite 4 square root of 2 over 7. Opposite over adjacent. Okay, so there's the sine, cosine, and tangent of angle B. Now let's find the sine, cosine, and tangent of angle A. And here we go. Alright. Okay, the sine of A would be opposite. Oh, we better label our sides. Sorry about that, students. So now we're no longer dealing with angle B. Okay, we're now dealing with angle A. Alright, so go straight across. This is my opposite side. This stays my hypotenuse, and this will be my adjacent side here. Okay, so here we go. Sine of A would be opposite over hypotenuse, 7 over 9. Cosine would be adjacent over hypotenuse, so 4 square root of 2 over 9. Adjacent over hypotenuse. And tangent is opposite over adjacent. This is going to be tough here, guys. This is going to be really tough. Opposite is 7. Adjacent is 4 square root of 2. So we got to do some work on this. Okay, guys, we never want to have a radical in the denominator, and we have a radical square root of 2 in the denominator. So watch what I do. I'm going to take 7, 4 square root of 2 times. Now we're trying to get rid of the square root of 2, so we're going to multiply the top and the bottom by the square root of 2. 7 times the square root of 2 is 7 square root of 2. And there's a 1 right here. So 4 times 1 is 4. And then square root of 2 times square root of 2 is just 2. So you multiply those. So you get an 8. So 7 square root of 2 over 8 would be the answer for tangent of A. 7 square root of 2 over 8. Let me check the answer key real quick and make sure that is correct. And see if it is. Yes, it is correct. All right. Okay. Moving on to number 22. All right. Let's start off with E first. This is my opposite side. This is my hypotenuse side. So this is my adjacent side over here. All right. So sine of E, cosine of E, tangent of E, and here we go. The sine of E would be opposite over hypotenuse, so 6 over 3 square root of 13, opposite over hypotenuse, multiply the top and the bottom by the square root of 13, and we're going to get 6 square root of 13 over, well, 3 times 1 is 3, square root of 13 times square root of 13 is 13, multiply those together and you'll get 39, okay? Now, we can reduce our two outside numbers because 3 goes into both of them. So 3 goes into 6 2 times, and 3 goes into 39 13 times. So 2 square root of 13 over 13. Alright, now let's talk about cosine, okay? The cosine of E, cosine is adjacent over hypotenuse. So the same problem again. We have to rationalize our denominator, okay? So adjacent is 9 over hypotenuse, 3 square root of 13. So we're going to multiply the top and the bottom by square root of 13 to get rid of our square root of 13 in the denominator, okay? So 9 over square root of 9 times the square root of 13 will be 9 square root of 13, and 3 times 3 square root of 13 times the square root of 13, well, 3 times 1 is 3, and square root of 13 times square root of 13 would be 13, so 3 times 13 would be 39, okay? 3 goes into both of those. 3 goes into 9 3 times, and 3 goes into 39 13 times, so I would have 3 square root of 13 over 13, okay? 3 square root of 13 over 13. Tangent is opposite over adjacent, 6/9, which reduces to, of course, 2/3. Okay, alright, now let's move on to angle F. Here's angle F. So this is my opposite side, this is my hypotenuse side, and this is my adjacent side right here. Okay, so we have sine of F, cosine of F, tangent of F. Now, here we go. Guys, think about this for a second. The sine of F is going to be opposite over hypotenuse, 9 over 3 square root of 13. Well, students, if you'll look in your notes, we just rationalized this exact fraction right here for cosine, okay? So if you'll look in your notes, we just did that, so I'm not going to redo that. I'm just going to tell you you'll get 3 square root of 13 over 13, okay? Now look at the cosine of F. That would be adjacent over hypotenuse. Adjacent over hypotenuse. Now, that would be 6 over 3 square root of 13. Now, here's the deal. Up here, when we were dealing with cosine or sine, we had this right here, and we had to multiply the top and the bottom by the square root of 13. In other words, if you'll look back in your notes, we've already rationalized this exact fraction, and here's what we got. 2 square root of 13 over 13. Okay, if you multiply the top and the bottom by the square root of 13, that is what you will get. Okay? Alright, and now tangent would be opposite over adjacent, 9 over 6, or 3 halves. Alright, moving on to number 23. Number 23. Let's see what we have here. Okay, we are going to go with, we will find J first. So this is my opposite side, this is my hypotenuse side, and this is my adjacent side here. Okay, so we're going to do sine of J, cosine of J, that's a C right here, cosine of J, and tangent of J. So here we go. Sine is opposite over hypotenuse, 6 over 8, which reduces to 3/4. Okay. Cosine of J would be adjacent over hypotenuse, so 2 square root of 7 over 8. Tangent would be opposite over adjacent, so 6 over 2 2 square root of 7. Multiply the top and the bottom by square root of 7, and you will get 6 square root of 7 equals, or over, excuse me, 6 square root of 7 over, well, there's a 1 here. 2 times 1 is 2. Square root of 7 times square root of 7 is 7. So 2 times 7 would be 14. Okay. Now you can reduce your outside numbers. 2 goes into both of them. So I would have a 3 here and a 7 here. So 3 square root of 7 over 7. Alright. Now let's go ahead and try the 3 trig functions of angle H. Okay. Angle H. So here we go. This will be my opposite. This will still remain my hypotenuse. And this will be my adjacent side here. Alright. So now we're going to find the sine, cosine, and tangent of angle H. Sine of H. Cosine of H. Tangent of H. Okay, students, here we go. So the sine of H would be opposite over hypotenuse. So 2 square root of 7 over 8. Now, we can reduce, I hope I reduced that over here. Let's see if I did, that's the wrong, you know what, I hope that I reduced that earlier when I had that up here for the cosine. I did not. Okay, guys, right here, earlier, this is my fault. This number here should have been reduced with this, so it should have been square root of 7 over 4. The 2 and the 8 could be reduced. Very sorry about that, okay? Alright. That's the wrong button to use. Alright. Okay, now, let's go ahead and try this again very quickly. Alright, so now, let's find the sine of H. The sine, cosine, and tangent of H. So this is opposite, this is hypotenuse, this is adjacent, so sine of H. And again, I'm not trying to win the NEAT Teacher of the Year award, okay? I'm trying to go fast here. Alright, sine is opposite over hypotenuse, so 2 square root of 7 over 8. The 2 and the 8 will reduce. Square root of 7 over 4, okay? Cosine would be adjacent over hypotenuse, 6 over 8, which is 3/4. Tangent would be opposite over adjacent, okay? So 2 square root of 7 over 6, and the 2 and the 6, of course, will reduce. So 1 square root of 7 over 3, and you do not need that 1 if you don't want it. Square root of 7 over 3 is acceptable. Okay. Alright, let's continue on. Number 24. Okay, now, let's start off with angle L. So straight across, this is my opposite side. Here's my right angle. This is my hypotenuse. This is my adjacent. So sine of L, cosine of L, tangent of L. Okay, so here we go. Sine is opposite over hypotenuse. So square root of 17 over 5. Okay, cosine is adjacent over hypotenuse. So square root of 8 over 5. Square root of 8 over 5. If I can get this to work here. And tangent is opposite over adjacent. So a little bit of work we got to do here, guys. My pen is really messing up. Hold on 1 second here. Okay. Square root of 17 opposite over adjacent. Square root of 8. Now listen, students, you're more than welcome to have a radical in the numerator. That's fine. So I don't care about this right here. But the square root of 8 has to go. So I'm going to multiply the top and the bottom by the square root of 8. Okay? So square root of 8 times square root of 8, which would give me 136. 17 times 8. I believe I did that in my head. Let's check it real quick here. 136. And the square root of 8 times the square root of 8 is 8. Now if you'll go back to your perfect squares, I believe 4 goes into this. Actually, I think 16 might, to be honest with you. Let's see. 16 times maybe not. No, I don't think so. But 4 would go into 136. So, students, we have to break this radical down, okay? I mean, you've got to simplify your radicals. And 4 goes into 136. 4 times, let's see, 3, 34 times, okay? So 4 times 34 is 136. Cross off the 4 and put a 2 on the outside. So now we have 2 square root of 34 all over 8. Reduce your outside numbers, and your final answer is square root of 34 all over 4. This becomes a 1, and this becomes a 4. Okay, now let's find the sine, cosine, and tangent of M, angle M, okay? So, not M, N, excuse me. So go straight across. This is your opposite. Here's your right angle. This is your hypotenuse. This would be your adjacent. So we're going to deal with sine of N, cosine of N, tangent of N. Here we go. The sine of N would be opposite over hypotenuse. So square root of 8 over 5. And to be honest with you students, really, I didn't catch this on the last round, but really I should break up my 8, okay? The square root of 8 is the same thing as 4 times 2. Cross off the 4 and put a 2 on the outside. So really we should have 2 square root of 2 over 5. I mean, I'm being a little technical, but really that's what you should put, okay? Would I take off for that on a test or a quiz? I very well might. So make sure you simplify your radicals. Okay, now cosine of N, adjacent over hypotenuse, so square root of 17 over 5, okay? Square root of 17 over 5. And then lastly, tangent is opposite over adjacent, so square root of 8 over square root of 17. So we're going to multiply the top and the bottom by square root of 17. And of course we already know from the last time we did 8 times 17, we get 136. And square root of 17 times the square root of 17 is 17. And we know 4 goes into 136. So I'm going to go ahead and put 4 times 34. Because 4 times 34 is 136. Cross off the 4, put a 2 on the outside. The 2 and the 17 cannot be reduced. So your final answer is 2 square root of 34 over 17. And a lot of students, and probably someone will do this on the test, because usually 1 or 2 students do this, they're going to reduce an outside number with an inside number, and that is not equal to 2. You cannot do that, okay? Alright, moving on to numbers 25 through 29, or 28. Now these problems here are really simple. I'm going to go through these pretty fast, okay? What they tell you in the directions, if you look in your book, it says this. Now listen carefully, okay? It says in the book, the geometric mean of SU and TU is ST. So ST is your geometric mean, okay? And ST, now listen to me carefully students, ST is the geometric mean of what two numbers? Well, SU and TU. And it says it right here in the directions. The directions say the geometric mean of SU and TU is ST. Okay, so ST is the geometric mean of these two numbers here, or these two sides here. Then it says this in the directions. Find ST. So for 25, 26, 27, and 28, we are going to find ST. And that's really pretty simple, guys. I've told you that whenever you are looking for a geometric mean, you just do this. I've told you guys this. Geometric mean equals the square root of the two numbers that you know being multiplied together. So if I'm looking for ST for all four of these problems, which I am, then what that means is I'm going to take the geometric mean of SU and TU. Okay, so SU is 5.2 times TU is 1.3. So it becomes a calculator problem, students. If I take 5.2 times 1.3, and hit enter, and then take the square root of that. I'm going to get 2.6, okay? And by the way, if you multiply those two numbers together, you get 6.76. Then take the square root of that, and you get 2.6. So the answer is 2.6. Then we're going to do this over and over for the next three problems, okay? So number 26, remember ST is the geometric mean of SU. So I'm looking for ST, so the geometric mean of SU, which is 45, TU, which is 20, okay? So 45 times 20 is going to give you 900. And we know the square root of 900 is 30, because 3 times 3 is 9, so 30 times 30 is 900. So the answer would be 30. The square root of 900 would be 30. Alright? Alright, same thing again, so here we go. ST is the geometric mean of SU and TU. We're looking for ST, so we're looking for the geometric mean. So the geometric mean of two numbers is the square root of the product of your two numbers, so 25 times 16, okay? When you multiply 25 times 16, you're going to get 400. So we have a geometric mean of square root of 400, and the square root of 400 is 20. So 20 is the length of ST. 20. Alright, number 28. Now ST is the geometric mean of these two numbers here. So geometric mean equals, or you could say ST equals, because ST equals geometric mean. ST equals SU 4.4 times 1.1. Okay, so 4.4 times 1.1 gives you 4.84. And then we're going to take the square root of that number. And you're going to get 2.2 for your answer. The square root of 4.84 is 2.2. Okay, so the answer is 2.2. So all four of those were done the same way. You're given two numbers, SU and TU, and you're told to find the geometric mean of those two numbers, okay? So not too bad. Alright, number 29, find the length of AH. Now, what I need to do here, students, is I need to mark some things here from the directions, okay? The directions say that I have a 4-inch square. That means this side here, and this side here is 4, and so is this side, and so is this side. Next it says, each triangle is an isosceles right triangle. Now what that means is, now remember, an isosceles right triangle means a 45, 45, 90 triangle. Please don't forget that, students, okay? So every triangle you see, I don't care if it's a big one like this, or a really big one like this, or if it's a little one like this right here. Every triangle that you see inside this shape is an isosceles right triangle, which means all of the little triangles inside of the square are 45, 45, 90 triangles, okay? 45, 45, 90 triangles. Because they're isosceles right triangles. That's going to help us, okay? Alright, moving on. The directions also say that E is the midpoint of AB. So that means from here to here is 2. And from here to here is 2. It also says that F is the midpoint of BC. So from B to F is 2. And from F to C is 2. The directions also say that J is the midpoint of HC. So I'm not sure how big this is right here. But J is the midpoint, so I'm going to put one little slash here and one little slash here, okay? And now I think what I really need to do is probably copy this and use this. So hold on 1 second, please, students. Okay, there we go. Okay, students, so here we go. Let's find the length of AH. The length of AH, alright? So here's AH right here. Now, let's see, how can I do this? Okay, I've got it. Look right here, guys. I have a triangle. This is my right angle right here. Okay, and this length here is 4. Now guys, what do we know about 45, 45, 90 triangles? So Mr. Earhart, we can't do this. We only know one side of the right triangle. That's true, but this is one of our special triangles, 45, 45, 90, and what we've learned is this, that you can take the hypotenuse and divide it by the square root of 2 to get the leg when it's a 45, 45, 90 triangle. You can do that, Mr. Earhart. Yeah, let's go back here, guys, real quick, okay? Hold on 1 second. My mimeopad is not working here. Okay, let's go back. Right here. The legs will be congruent. The hypotenuse is square root of 2 times the leg, and the leg is the hypotenuse divided by square root of 2. So if we're given the hypotenuse, we can divide it by the square root of 2. Then we're given the hypotenuse, so we take the hypotenuse divided by the square root of 2. Okay? So hypotenuse divided by square root of 2. Of course, we don't want the square root of 2 in the denominator, so we multiply the top and the bottom by the square root of 2. 4 times the square root of 2 is 4 square root of 2. Square root of 2 times square root of 2 is just 2. Then reduce your 2 and your 4. 2 square root of 2 over 1, or just 2 square root of 2. Okay? So thinking outside the box here, not super easy. We really got to think, okay? Alright, let's take a look at number 30. We're going to find the length of EF, okay? Well, guys, look, here it is right here. EF. Is that not a right triangle right here? Sure it is. Right there it is. 45, 45, 90 triangle. So here's your triangle right here. We have a length of 2 here, a length of 2 here, and we're trying to find this. Well, you could use Pythagorean's theorem, but you don't need to. Remember, this is a 4, and by the way, you're welcome to use Pythagorean's theorem. It's longer, but you can do it. 2 squared plus 2 squared equals x squared. That would be 4 plus 4 equals x squared. That's 8 equals x squared. Square root of both sides, square root of 8 equals x. Then simplify your radical. But there's a faster way to do this, guys. Remember what you've learned. Whenever you have a 45, 45, 90 triangle, if you know one leg, you multiply by the square root of 2, and you have the hypotenuse. So take your leg 2 and multiply it by the square root of 2, and you get 2 square root of 2. No, that's the exact same answer you would have got down here, because 8 breaks up into 4 times 2. Cross off the 4 and put a 2 on the outside. So Pythagorean's theorem works, but it's a lot longer. And so I would encourage you to use these shortcuts of a 45, 45, 90 triangle. Alright, let's take a look here at number 31. Find the length of EI. Now here's EI right here, got it? So look, I've got a little triangle right here. That's a 45, 45, 90 triangle right here. And this length here is 2. Now I'm going to find this length here. Now remember, this is the right angle here. So this is the hypotenuse. So if you're given a hypotenuse in a 45, 45, 90 triangle, how do you find the leg? You take the hypotenuse and you divide it by the square root of 2. Always. If you're given the leg, you multiply by the square root of 2 to get the hypotenuse, okay? But we're given the hypotenuse, so we divide it by square root of 2. Well, we don't want that radical in the bottom, so we're going to multiply the square root of 2 over the square root of 2, which gives you 2 square root of 2 over square root of 2 times square root of 2 is 2. So then these cancel out, and you're just left with square root of 2, okay? Not too bad. Alright, number 32. Find the length of GJ. Now this is going to be tough, okay? I'm going to be honest with you. This is going to be a pain. I'm going to use a little bit of common sense. Let's go back to here. We found the length of AH. Got it. AH right here is 2 square root of 2. Alright, so AH from here to here is 2 square root of 2. Alright, now guys, it does make sense. It really does. If you have a square, which you do, and you have all of these right triangles, then we do know for sure that H has to be right in the middle of the square. So if AH is 2 square root of 2, which I think is what we said, then I know that HC has to be 2 square root of 2. Okay? Right here. So this whole length right here which means we need this triangle right here, okay? This is our x right here, G, J. Now, if we're trying to find this length here, if I know this whole length from H all the way to C is 2 square root of 2, and I know that J is my midpoint because they told me that already, then I can cut this in half, divide it by 2, and I'm left with square root of 2. Think about it, guys. If from H to C is 2 square root of 2, which it is, because from A to H we had 2 square root of 2. So from H to C is 2 square root of 2. Then this is a midpoint right here. They gave that to us in the directions. J is the midpoint. Then that means this segment here is congruent to this segment here because J is right in the middle. So take your entire length, 2 square root of 2, cut it in half, divide it by 2. These cancel, and HJ is square root of 2. So there. Now I know the length of one of my legs. So in a 45, 45, 90 triangle, when you know the length of a leg, how do you find the hypotenuse? Well, you always multiply the leg by the square root of 2. So here's your leg, square root of 2. And we're going to multiply it by square root of 2. Square root of 2 times square root of 2 is just 2. And the answer is 2. Okay? Alright, not too bad. Okay, this sounds really hard, but it's really easy. Your flight to Chicago is 589 miles. I think I better read the directions up above. Alright, the directions up above say you live in Atlanta and your friend lives in Memphis. So when it says your flight to Chicago is 589, that means you live in Atlanta. So your flight from Atlanta to Chicago is 589 because it says in the directions you live in Atlanta. Okay, then it says in the directions you live in Atlanta and your friend lives in Memphis, 336 miles away. So Memphis is 336 miles from Atlanta. So that means this length right here has to be 336. Okay? So next what I'm going to do is, the question now says, how long is your friend's flight? Now your friend lives in Memphis, and it says you're both going to fly to Chicago, okay, to attend a science fair. So I would rather fly to Chicago to see Derrick Rose play for the Chicago Bulls, but nonetheless. So your friend is leaving Memphis and going to Chicago, okay? So this is what you're looking for. What is the distance? Well, guys, this is good old Pythagorean theorem. We have a right triangle, and we know 2 sides. We can find the third side pretty quickly. One of my legs is x. I better slide this over to get a little bit of room here. Okay, one of my legs is x. My other leg is 336. And my hypotenuse is 589. Alright, well here we go. Let's break out the calculators. 336 squared is going to be 112,896. 589 squared is 346,921. Okay, now bring this over and make it a negative number. 921, there we go. And let's see what we're left with. X squared equals, let's see, make that a 1, that'd be a 5, that'd be a 2, 0, 2, 3, 4. Okay, now take the square root of both sides, and you're going to get 483.761308. So approximately 484 miles if you round to the nearest whole number. Alright? And they did not. They rounded to the first decimal place, which is fine. Now what theorem did you use? Pythagorean's theorem, obviously. Pythagorean's theorem, okay? Alright. Numbers 35 and 36. Now these are a little more difficult, okay? So please pay attention. On 35 it says this. Raymond is 65.5 inches tall. His shadow is 55 inches long. What is the approximate approximate angle of elevation of the sun. Now, angle of elevation means you start down here and you elevate up to the sun. So you know that, okay? So you must have a parallel, you must have a horizontal line, and then an angle of elevation goes up to the target, or to the area mentioned. In this case it says to the sun. So this right here is your missing angle. Got it? Now, I want to show you something that's really, really interesting. Please watch this, students, okay? We have a triangle here, okay? Remember, it says the shadow from where he's standing. Here he is. He's this tall, 65 and a half, and his shadow is 55 inches, okay? Now, what I want to show you is this. This line here is parallel to this line here. How do you know that, Mr. Hart? Because the sun is forming the same shadow. So the sun is hitting this object here and shining down. It's hitting this object here and shining down. So really, you could pick this triangle up here, okay, and slide it. And I'm not sure how to do this. I'm not sure what just happened there. That's what I was afraid of. Okay, well, anyways, I was hoping we could put one on top of the other, but maybe not. Maybe that'll do it. Let's see. Okay, good. So, what I want to show you was this. This triangle would really fit right inside this triangle here. That's what I wanted to show you, okay? See that? This triangle here is going to fit right inside this triangle here. So when we're asked to find the angle of elevation to the sun, students, and by the way, you say, Mr. Hart, how do you know this line is parallel to this line? Guys, because this guy here, I'm imagining he's standing straight up, and I'm imagining your basketball hoop is not tilted, it's straight up. So this line here is parallel to this line here, and thus that's how I know that my angle that the sun is hitting these two objects equally, thus giving me this line right here that's the same. So what I'm looking for, this angle right here, angle X, that's the same thing as looking for this angle right here inside of this triangle. Okay, so I'm going to draw it off to the side here. This is 65.5. This is 55. And I'm looking for this angle right here. Now remember, we've learned how to solve right triangles. So this is the angle they've given to me. So go straight across. This is your opposite. This is your hypotenuse. This is your adjacent. Now what two sides do you know? Opposite and adjacent. So if I'm going to find this angle right here, students, I have to use a trig function that has opposite and adjacent. Well, that would not be sine. Sine is the opposite over hypotenuse. It wouldn't be cosine. Cosine is adjacent over hypotenuse. Okay? It would be tangent, because tangent of x, the angle you're looking for, tangent of x equals opposite over adjacent to it. Now, are you missing the angle? Yes. So this is where you hit second tangent or inverse tangent. And then type into your calculator 65 divided by, or 65.5 divided by 55. Be sure and use parentheses when you type that in, okay? Parentheses. 65.5 divided by 55. And then close your parentheses, alright? Let me grab my calculator real quick. Let's see what we get here. Make sure I'm in degrees, or in rate in degrees. And what I'm getting is this. I'm getting the angle is 49.97. So they put 50.0. They rounded 50.0. Okay, guys, I hope that makes sense. Back it up and watch again if you need to. It's a really good word problem and a really challenging word problem. Okay, now. At the same time, the length of the shadow of the backboard is 10.5 feet, okay? What is the approximate height of the top of the backboard? Well, guys, come on. We just learned this angle right here was what? Remember, we just learned this. 50 degrees. So I have a right triangle right here. I have a right triangle right here, okay? Let me get rid of this picture. I think it'd be a little annoying. I've got a right triangle, and I'm trying to find how high the backboard is from the ground, the height of the backboard, okay? So think about it. I know this. I know one side of the triangle is 10.5. How can I find this missing side? Well, again, what two sides are we dealing with? If this is 50, I go across. This is my opposite side. This is my hypotenuse side. This is my adjacent side. So I've got to use a known side. I don't want to use two unknowns. That makes no sense, okay? I've got to use a known side. 10.5 adjacent, and the side that I'm trying to find, which is this side here, x, or my opposite side. So I'm going to be dealing with opposite and adjacent. Now, which trig function has opposite and adjacent? Well, we just dealt with a tangent. So we're going to say the tangent of what? 50 degrees equals opposite over adjacent. Now, multiply both sides by the denominator. Before I do that, though, don't forget tangent of 50 is an actual number, a decimal. So the tangent of 50 is 1.1918 equals x over 10.5. Now, multiply both sides by 10.5. If you multiply the left side by 10.5, you'll get 12.51. If you multiply the right side by 10.5, you will get x. Okay? So there we go. The height of the backboard is 12.51 or 12.5 feet. Okay? Guys, I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.